Okay guys, good morning. Today I'm gonna talk about this piece of device here. This is a 5 kilowatts charge control board. This is always found in the some branded and cloned versions of voltronics products. So as you can see, this is defective, but I'm gonna fix that. Though I'm not going to do a live video of how I'm going to fix it, but I'll explain exactly what I'm going to do. Okay, this device is burnt, and as a result we'll not see solar inputs. When you connect any solar inputs here, the inverter which it is present in, it's supposed to see it, but it's not gonna see because the active section of this unit is bad. So, but before I go further, what I want to do now is to do a dissection or an anatomy. I'm going to explain the concepts, how this charge controller works. This is an mppt type of charge controller. So, let's start with the sections before I go into explaining the particular fault that is related to this one. Now, these are NTC resistors that are used to sense the thermal, or you can call them thermal sensors, that are used to read the thermal characteristics of these blocks here. And these blocks are just a cooling patch for this set of MOSFETs that you can see there. I don't know how clean you can see that. Yeah, you can see them now. Yeah. So you can see, so these are capacitors that will filter out the input voltage that will come from here. Now, flipping it over, you can see these are the footprints. These are the footprints here. And then you also have footprints here of the MOSFETs that are used. You can see here, this is a driver and this is a driver. What these drivers actually do is to do a buck conversion using this the MOSFETs like a switch. These are still capacitors, you know. So basically what happened is that this is a buck, or a buck converter section, which takes in your inputs, whatever voltage that is supported, converts it back to the voltage that is required to power the battery, or also power the load that is connected. And then these two guys here are diodes, which rectifies a source that's giving an input given to them, and then this ones takes in power from here and powers up, then doing the buck conversion. So this guy is bad. Yeah, you can see this guy is bad. This guy over here, it burnt. No, maybe I need to. So that guy over there is burnt. These over here are resistors, which links these wires. These wires are high gauge wires. They are used to connect to the inductors, which will further, be able to allow this buck converter to do its work properly. Now, this is a transformer that is going to feed these diodes here that has been damaged. So you can see physically that this guy is also damaged. This is the MOSFET that would drive this guy. This transformer needs to be changed. And then this is the controller that does all the logic operations for this guy for this whole device. Okay, down here you can have some other things like current sensors, up arms, and all of that to be able to give signal to this guy, so he can do a lot of things. Here you can see the JTAG serial communication ports that you can talk to the microcontroller, but we are not going to go into that. This is the relay. It acts both like a protection feature for polarity protection and also as a means of connecting the converter to the power line and the coil, something like that. So over here is your communication line. This is where you can control this chip from any external device, and this is where you can use to trigger the external device to sense that this chip is actually working. This is fit by these guys. We are not going to go into details of that. This is optical class, but we won't go into details. So basically, how does this guy fail? There are many ways with which it will fail. Let's assume this is working, this control section is working properly. This unit needs a power source, which is generated from here by this transformer section as an SMPS converter in inverter mode. Converts that power, gives to these two guys. These two guys use it to run their buck circuit to produce another voltage, which is now used to charge the battery or used to power other loads. So that's it. Now the failure here is that, which is a very common one, this guy over here was shorted, thereby leading to a demand for it took a large current from the SMPS circuits that generated that voltage, the source voltage, the input voltage for it. So as a result of that, it has burnt. You can see, if I should poke that around, I don't need to poke it anyway. It has burnt. So because it's burnt, it did not just fry out at once. It went as far as taking too much current that this one has to burn, and then this one has to burn as well. Now you can see here, this one is bad. There's a trace there, a via that is supposed to connect the upper part of the I guess you can see it now clearly. This via is supposed to link this trace to the other side. It's supposed to link this trace to this terminal over here, but that's not possible because it is open now. So what now happens is that this guy no longer sees power to generate, and it's shorted and burnt already, and this one here is also burnt. So what we'll do is we are going to change this. We're also going to change this. By the time we replace this one, and also replace this unit will work back. Maybe we'll do another video of us after we've replaced those components, try to test this device. Thank you. So if you have this problem where you have this guy, this place burnt, or it cannot sense solar, check these things that they are okay. Once those are okay, then the problem is not from the side, it should be from here, but that's rare. It's a rare situation where you have issues from here to do that. Yeah, so it's issue that is related to this SMPS section and this buck converter. That's where you have a no solar issue. Thank you, and watch out for another video. You can give us thumbs up if this video was helpful, and you can also subscribe to our channel to get more videos from us.